Great day, Star Louisians. Welcome to the fourth week of our video discussion. In the previous recorded discussion we have given you have learned that exponent is an excellent example of good mathematical notation. Indeed, exponents are powerful tools in the study of elementary algebra. You have also noticed how important the first three laws of exponents in simplifying now algebraic expressions, and that I would like you to always remember that the exponent of a number says how many times to use the number in multiplication. For this week's video discussion, it will focus on the other four laws of exponents, namely, we have the quotient of two powers, power of a quotient, and zero and negative exponents. And for the information of everyone, may I introduce the exponents structure. One of the trickiest concepts in algebra involves the manipulation of exponents or powers. Many times, problems will require you now to use the laws of exponents to simplify variables with exponents. Or you will have to simplify now an equation with exponents to solve it. And to work with exponents, you need to know the basic exponent rules. In mathematics, there are different laws of exponents. All the rules of exponents are used to solve many mathematical problems which involve now repeated multiplication processes. And the laws of exponents simplify the multiplication and division operations and help to solve now problems easily and accurately. So this time, I'd like to present to you now the fourth law of exponent. May we have the different examples? So under the fourth law of exponent, this is what we call now the quotient rule. Quotient rule. Okay. So anong ibig sabihin natin kapag ang pinag-uusapan ay quotient rule? Ang ibig sabihin po ng quotient rule is that when dividing powers with the same base, what will you do? You just have to keep the base and subtract the exponents. So how are we going to deal with this one? So simply, what will be the step that you need to follow? You have to keep the base. Yeah, I just gonna explain. Yeah. So we have to keep the base, and after keeping the base, what will you do with the keep the base? So keep the base, and you are going to subtract the exponents. Or you have to divide the base and subtract the exponents. So this will be the rule that you are going to follow under the fourth law of exponent, which is the quotient rule. When dividing powers with the same base, you have to keep the base and subtract the exponents. Example, number 1. Say for instance, we have 2 raised to 5 divided by 2 raised to 2. Following now the rule under quotient, law of exponent, what will we do? We have to keep the base of the given expression. So, we have common base 2. Pareho. Ito po yung base. Okay? Ito po. Pareho po sila ng base. So, we keep the base, keep the common base, and what will we do with the exponent? we have to subtract the exponent. So 5 minus 2. And then after that one, what we are going to do is to simplify now the expression that will give us now 2 raised to 5 minus 2. That will give us a difference of 3. 2 cubed is not yet the final answer because we can still expand this one. So we have 2 times 2 times 2. This will give us a product of 8. So our final answer should be 8. Because 2 raised to 5 divided by 2 raised to 2 will give us an answer which is equal to 8. Next, number 2. How about if we have 9 raised to 15 divided by 9 raised to 13? Kung mapapansin nyo, sa numerator, ang base ng exponential expression is 9, while the base of the denominator is also 9. So they have the same bases. So what are we going to do? We just need to keep the base and then we have to subtract the exponent. So we keep the common base that is 9. What will we do with the exponents of the numerator and the denominator? We have to subtract. We have 15 minus 13. And then we simplify. That will give us 9. 15 minus 13. That will give us a difference of 2. And we have to simplify 9 squared. That will give us 9 times 9. It's equal to 81. Okay, next. Number 3. How about if we have 5 raised to 11 divided by 5 raised to 9? So kung mapapansin nyo, i-check nyo muna yung bases. If the bases are the same, okay, when you are dividing powers with the same bases, okay, and what is the base? What is the common base in the given? We have 5. Pareho sila ng base. So what will we do with the exponents? We subtract them. So we have 11 minus 9. Simplify. That will give you 5 raised to 2. Where did we get 2? We just simply get the difference. Okay, 11 minus 9, the difference will give us 2. Okay, because 11 minus 9 is equal to 2. And then we have to simplify 5 squared. That will give us 25. So that's how simple quotient rule is. Next, we proceed with, so kung mapapansin nyo, first 3 examples, ang ginamit ko na bases are numerals or constants. This time, we proceed with variables. How about if we have variables as our bases? Still, we have to follow the rule under quotient, law of exponents, x raised to 8 over x raised to 7. What is the common base? X. So, pareho silang may x. That's why we keep the base, which is equal to x. And then, what will we do with the exponent? We have to subtract them. So, 8 minus 7, it will give us a difference of, x is equal to, 8 minus 7 is equal to 1. Okay, and then we simplify x raised to 1. Any number that is, or any variable or any number that is raised to 1 is equal to the number itself or to the variable itself. Or anything that is being raised to 1, it's equal to that particular thing given. So this is equal to x. So x raised to 1 is equal to x. Okay, so that's how you solve or you deal with the quotient rule. Another example. I'll just move the board. Okay, so we're still under quotient rule. We proceed with example number 5. Example number 5, say for instance we have x raised to 19 over x raised to 11. So what are the rules that you need to use? Okay, we apply the quotient rule, and then after applying the quotient rule, we keep the same bases. So we have x as the base of the numerator and the denominator. So we have to keep it. And then after keeping the base, what will we do with the exponent? We have to subtract them. So 19 minus 11, it will give us x raised to 19 minus 11, it's equal to 8. Okay? So our final answer would be x raised to 8. Okay? Ito na po yung answer po natin. Next, number 6. How about, so I have presented to you examples of variables, okay? A while ago, from the first 3 examples, we have constants as the basis of the given exponential expressions. And then I have presented to you variables as the basis. This time, we proceed with the combination of the two. How about if we have a combination of a variable and a constant as our basis? So we have here, for example number 6, we have 14x raised to 31 divided by 2x raised to 11. So kung mapapansin nyo, okay, we depend on the variables, okay? Pareho sila ng variables, okay? So we can simplify the given exponential expression. What will you do with the constants? You have to divide as it is. So 14, okay? 14, the numerical coefficient of the numerator is 14, while its literal coefficient is x variable, okay, raised to 31. So paghiwalay nyo para hindi kayo malito. And then what is the numerical coefficient of the denominator? We have 2. While for the literal, still we have x also that is being raised to 11. Okay, and then what will you do next? You simplify, you divide. 14 divided by 2, that will give you 7. And then, what will you do with the variables? Okay, same variable, same bases. Copy the base, or you keep the base, keep the common base, that is x. And then what will you do with the exponents? Subtract 31 minus 11. And then that will give us now 7x raised to 20. So that's now our final answer. So 7x raised to 20. Okay? So kapag may mga constants, okay lang yon. I-divide nyo lang siya as it is. Okay? Mas magandang paghiwalayin nyo yung constants sa mga variables or containing exponents para hindi kayo malito. Let's proceed with our next example. How about if we have 42x raised to 19 over 3x? Okay? So, ganun din. 42 divided by 3 times, pareho silang may x raised to 19 over x. What will we do? We divide 42 by 3. 42 divided by 3, that will give us a quotient of 14. And then what will we do with this one? X raised to 19 over x. We copy or keep the base, which is x, and then we subtract the exponent. So 19 minus 1. There is an imaginary 1 here. Okay? So we now have 14x raised to 18 as our final answer. Okay? Next, number 8. How about if we have negative 55 x raised to 39 over 5x raised to 19. Ganon din po. So, paghiwalay natin yung constants at saka yung variables. So, negative 55 divided by 5 times x raised to 39 over x raised to 19. So, negative 55 divided by 5, that will give us negative divided by positive, it will give us a negative answer. And 55 divided by 5 is equal to 11. So, the answer there, or the quotient, is equal to negative 11 times, we copy or keep the base, which is x, and then we subtract the exponents. 39 minus 19, it will give us now an answer which is equal to negative 11 x raised to 20. Very good. Okay, I hope that's clear. So we have under quotient rule, what will you do is you just need to keep the base and subtract the exponents if you are dividing now powers with the same bases. Okay. Another one. So we have last two examples under this rule. Let's say we have example number 9, 18x raised to 8 y raised to 9 divided by 2x raised to 5 y raised to 7. How will you deal with this given problem? Okay, so hindi lang iisa yung variables na ginamit na, kung hindi more than 2. Okay, to be exact. Okay, so dalawang variables ang ginamit. So same process, ihiwalay natin siya, 18 divided by 2 times, you factor out the given expression, x raised to 8. May x variable ba sa denominator? Meron. So we keep x raised to 5. And then we proceed with the next variable, that is y raised to 9. May ginamit bang y sa denominator? Meron din. That is y raised to 7. So we now have 18 divided by 2. That will give us a quotient of 9. And then times x raised to, what will you do? We subtract the exponent, 8 minus 5 times y, keep the base, and then subtract the exponent, 9 minus 7. So it will give us now 9x raised to 3y squared. So this will serve as our final answer. So that's how you simplify now problems under the fourth law of exponent, which is the quotient rule. This time we proceed with the fifth law of exponent. Okay, how about the fifth law of exponent? Okay, so the fifth law of exponent is what we call now the power of a quotient. Okay, so magkaiba po ang quotient rule sa power of a quotient. Okay, please take note of that. Magkaiba po ang power of a quotient sa quotient rule. Paano sila, saan sila nagkakaiba, sir? Okay, so when we talk about power of a quotient, if the quotient of the bases is powered by the same exponent, what will you do? The result is both numerator and denominator, each powered by the given exponent. I repeat, once we deal with the power of a quotient, if the quotient of the bases is powered by the same exponent, then the result is both numerator and the denominator, each powered by the given exponent. Say for instance, we have a over b, the quantity raised to x. How do we apply the power of a quotient? We just need to distribute x in each term that we can see inside the parentheses, or we distribute x from the numerator, also from the denominator, so that it will give us a raised to x over b raised to x. Okay, so say for instance, we have problem number 1, 2 over 3, the quantity raised to 4. So what will we do? We distribute the exponent to the bases, and then after that we simplify our solution. So we distribute 4 to 2 and 4 to 3. So that this will become now 2 raised to 4 over 3 raised to 4. Okay, so this will give us now 2 times 2 times 2 times 2, because you are going to multiply 2 4 times by itself since the exponent is equal to 4. While for the denominator, we also have 3 times 3 times 3 times 3. And then simplifying, this will give us now an answer which is equal to 16 over 81. Always remember to simplify your answer to lowest term. Can we still think of a factor of 16 and 81? Meron pa ba silang factor so that we can simplify it in its lowest term? Wala na po. So our final answer is 16 over 81. So that's how we solve problems under power of a quotient. Example number 2. How about if we have 5 over 4, the quantity raised to 2? Okay. How will we solve this one? So, ganun pa rin, we distribute the exponent doon sa numerator at saka sa denominator. Or, simply, you have to distribute the exponent to each base, okay? Or doon sa base na nandun sa, given sa problem. Okay? So, distribute the exponent to the bases. So, we have 5 squared over 4 squared. Then this will give us now 5 squared, it will be equal to 25. Why? Because 5 times 5 is equal to 25. And 4 times 4, it will give us a product of 16. 25 over 16. Can we still simplify 25 over 16? Can we still think of a factor, common factor of 25 over 16? Wala na po. So the final answer would be 25 over 16. No need for you to what do you call this one, to translate the improper fraction or to convert the improper fraction to a mixed number. Wag na po. Ganyan na lang po. Hayaan yung improper na lang po ang sagot. Okay? Next, we proceed with example number 3. How about if we are dealing with variables? From the first two examples, as you can see, constants, or they are fractions, okay? Fractions in terms of numbers or constants. This time, fractions dealing with variables. How about if we have the quantity x over y raised to 11? So what will we do? Still, we distribute the exponent to the bases. This will give us now x raised to 11 over y raised to 11. Ganun lang po kasimple. And this is now our final answer. We cannot divide x raised to 11 over y raised to 11. Why? Because they differ in terms of their bases. The numerator has a base of x while the denominator has a base of y. So we cannot subtract 11 here, which is the exponent of x, and the 11 also in the denominator, which is the exponent of y, because they differ in terms of their bases. Hindi po pwede. Okay, so the answer is x raised to 11 over y raised to 11. How about if we have now a combination of a variable and a constant as our numerator and our denominator? Say for instance, we have x raised to 4, the quantity raised to 2. So we have now, we distribute the exponents to the base. So x squared over 4 squared. So we simplify x squared over 4 squared, that will give us 60. So the final answer would be x squared over 60. Another example, we have number 5. R over S, the quantity raised to 9. Still, we distribute the exponent to the bases or to the base. We have r raised to 9 over s raised to 9. Ganyan lang po kadali. That is our final answer. Next, number 6. How about if we have 5 over 7, the quantity raised to 2? So we distribute 5 squared over 7 squared. Okay, anong ginawa ko? Dinistribute ko yung 2, yung exponent, doon sa numerator at saka sa denominator. And then after distributing, you have to simplify. 5 squared, that will give you a product of 25, while 7 squared, that will give you a product of 49. And then, mag-isip ng common factor ng 25 at saka 49. Isipin nyo kung meron siya, meron pa, because in math, you always have to simplify your answer to its lowest term. And 25 over 49, meron pa bang common factor? Wala na po. That is why 25 over 49 is already our final answer. Okay? Next. one additional rule on exponent involves also negative exponents. Note that, so remember that when we say 3 cube over 3 raised to 5, okay, this will give us now, they have the same basis. We apply the quotient rule. What will we do? We copy the common base or keep the base, which is 3, and then we subtract the exponent. So 3 minus 5. And this will give us now 3 minus 5, negative 2. What do you notice with the exponent? It's a negative exponent. And we cannot, in math, we cannot leave our answer with negative exponent. That is why we need to apply now the next rule, or the sixth rule, or the sixth law rather, of exponent, which deals with the negative law of exponent. So, kaya po meron po yung existence ng negative law of exponent. At anong ibig sabihin ng negative law of exponent? Anong gagawin natin kapag negative law of exponent ang naibigay? The rule is, if the base is powered by a negative exponent, then the base becomes the reciprocal with a positive exponent. Take note, if the base with a negative exponent is found on the numerator, it becomes the denominator. While if the base with a negative exponent is found on the denominator, it becomes the numerator. Okay, you will understand that one as we go through with the different examples that I'm going to present afterwards. But we try to look on this one, 3 raised to negative 2. How will we deal with this one? Basing now on the rule I have presented, or the law I have presented a while ago. Following that is, we have to take the reciprocal of 3, 1 over 3. Ano yung kabaliktaran ng 3? Remember, may denominator yan na 1. So, baliktarin niya siya. That's the reciprocal 1/3. And then, where will we put now the exponent so that it will become positive? Okay, dalhin siya doon sa denominator. Okay, so we have 1 over 3 squared. This will become 1 over 9. So that 3 raised to negative 2, the simplified form of this one now is 1 over 9. Okay, next, so anong ginawa natin? Bakit naging 1 over 9? We get the reciprocal of the base. Anong base ba natin? It's 3. We get its reciprocal. Its reciprocal is 1 over 3. And then we make the exponent positive. Okay, at para gawing positive yung negative, dalhin natin yung 2 doon sa baba, sa denominator. Okay, or doon sa 3. Okay, so 1 over 3 squared, it will give us 1 over 9. Another example. So this will serve as our first example now. Our second example would be 2 raised to negative 5. Ganon pa rin. Ano ang reciprocal ng 2? Take note, may over 1 yan. So kabaliktaran ng 2, it's 1 half. And then we put 5, the positive exponent now, doon sa denominator, kasi sabi doon sa law ng 6th law of exponent, which is the negative exponent, is that if the base with a negative exponent is found on the numerator, o yung 2 po ang tinutukoy na base, okay, is found on the numerator, nasa numerator siya kasi ang denominator nito 1. Okay, what will we do? It becomes now the denominator of the answer. Kaya po naging 2, nasa baba na siya, nasa denominator na siya. Sa given, nasa numerator siya. Since may negative exponent siya, nasa baba na siya. And then you carry now the absolute value of negative 5, which is 5. Okay, so 1 over 2 raised to 5, it will give us an answer now which is equal to 32. So 1 over 32. 2 times 2, that is 4, times 2, that is 8, times 2, that is 16, times 2, that is equal to 32. So it will give us an answer of 1 over 32. We proceed with our next example, number 3. How about if the given is a combination now of a constant and a variable? Say for instance, we have 2x raised to negative 5. Okay? Saan dyan yung naka-raise lang ng negative exponent? yung variable x lang. Hindi na raise ang 2 ng negative exponent. Why? Ano ba ang exponent ng 2? It's 1. Okay, so what will we do? We apply now the negative law of exponent. Notice that the exponent negative 5 is raised only to the base x. So, tignan nyo kung saan lang ba meron yung negative exponent. Nasa x lang siya. Wala siya sa 2. Kasi ang exponent po ng 2 ay 1. So, we get the reciprocal of the base a and then make the exponent positive. So, ititira natin yung 2 sa numerator. Saan natin dadalhin yung may negative exponent sa numerator? Sa baba. So, magiging x yan, and then gawin nating positive yung exponent. So, that's how simple we apply now the negative law of exponent. So, this is now our final answer, 2 over x raised to 5. Remember, yung 2x raised to negative 5 may denominator yan na 1. Ang sabi sa negative law of exponent, kapag yung numerator expression ay negative exponent siya, or may negative na exponent yung expression, dadalhin siya sa denominator. Kaya naging x raised to 5. Yung x raised to 5 nasa denominator na siya. Wala na siya or natanggal na siya sa numerator. Why? Because it contains a negative exponent. Next, number 4. So, mabilis lang to. How about if we have x raised to negative 7 over y raised to negative 3? Okay, tandaan. Ano ulit yun? Take note. Kung yung numerator ay negative, may negative exponent, dadalhin siya sa denominator. So, balikan natin yung problem. Yung x raised to negative 7, may negative exponent ba siya? Meron. That is negative 7. So, anong gagawin natin sa x raised to negative 7? Ipupunta natin siya sa denominator. Why? Because negative exponent yung numerator. So, kailangan dalhin siya sa baba. So, magiging x raised to 7. That's it. How about yung denominator natin? Y raised to negative 3. Nasa denominator siya, negative siya. So, kailangan ipunta siya sa taas. So, it will become y raised to 3. So, that's how simple you simplify now things or expressions, exponential expressions under negative law of exponent. So, our final answer would be y cubed over x raised to 7. We cannot simplify y cubed over x raised to 7. Why? Because they differ in terms of their bases. Okay? That's why we cannot subtract 3 and 7. Okay? Next, number 5. We proceed with number 5 example. How about if we have 11 over r raised to negative 8? Okay, i-check nyo kung saan yung expression na may negative exponent. Kung nasa numerator siya, dalhin nyo siya sa denominator. Kung nasa denominator siya, dalhin nyo siya sa numerator. Okay, in this case, 11, meron ba siyang exponent na negative? Wala. So, dyan lang po siya sa may numerator pa rin, 11. How about sa denominator? R raised to negative 8. Tama. Meron siyang negative exponent. That's why kailangan dalhin siya sa taas or sa numerator at magiging r raised to 8 na siya. Ano yung natira sa denominator? 1. So, our final answer would be 11 r raised to 8. Okay? Ganyan lang po. Kasimple ang application ng negative law of exponent. Okay, next. How about if we have now the application of, say we have the application of the quotient rule and the negative law of exponent. Negative laws of exponent. Okay? Paano nyo i-evaluate yung given na problem dealing with the application of the quotient and the negative law of exponent? For example, we now have number 1. Say for instance, we have x raised to 9 over, or let's say palitan natin, x raised to 5 over x raised to 9. Eh, kung mapapansin nyo sa given na problem, they have the same base, right? So we can apply now the quotient rule since we are dealing with division as our operation. So we have to keep the base, keep the common base, which is x. What will we do with the exponent? We subtract them. So 5 minus 9. So this will give us now x. What is the difference? 5 minus 9 is equal to negative 4. And if we're dealing with exponential expressions or problems under exponential expressions, we are not, what do you call this one? We should not leave, or we cannot leave our answer with a negative exponent. That's why what we are going to do is we have to simplify this one using now the negative law of exponent. So ang una natin ginamit is yung quotient rule. Okay, quotient rule po ito. This is the quotient rule, and this one will be under the negative law of exponent. And then we apply the rule under negative law of exponent. X raised to negative 4, this will become 1 over x raised to 4. So ipupunta natin yung x sa numerator sa denominator. Yung x is numerator siya, that's why ililipat natin siya sa denominator. And ang magiging numerator na natin ay 1. So we get the reciprocal of x. What is the reciprocal of x? 1 over x. Take the positive exponent. Negative 4 will become positive 4. And the final answer would be 1 over x raised to 4. Next example. How about if we have now, what do you call this one? Say for instance, we have 4 x raised to 3 y raised to, let's say, 5 over 2x raised to 7 y raised to 3. Okay. So we apply now the quotient rule and the negative law of exponent. So with this one, we have now 4. Paghiwalayin natin yung constant at saka yung variables. 4 divided by 2, x cubed minus 7 times y raised to 5 minus 3. Tama? So we have now 4 divided by 2. This will give us 2 as a quotient. And then x raised to negative 4, y raised to 2. Okay, where did I get negative 4? 3 minus 7, that will give us a difference of negative 4. And then as you can see, there is a negative exponent under x variable. So we have to simplify our answer. So magiging yung may negative exponent na nasa numerator, dadalhin natin sa denominator. So magiging ang answer natin 2y squared over x raised to 4. So nilipat natin itong x raised to negative 4 sa denominator na. That's why meron na tayong answer na 2y squared over x raised to 4. So that's how we deal now with the application of the quotient rule and the negative laws of exponents. Okay? I hope may natutunan kayo with this one. Okay. Next is, we proceed with the next example. How about if we have now, let's say, 24a cubed. Okay? Example number 3. Say we have 24a cubed. What's that? 24a cubed b raised to 7 c. 24a cubed b raised to 7 c over, let me just check the problem, 32a raised to 5, 32a raised to 5, b raised to 4, c cubed, and c cubed. Okay. Let's take this one as our last example under the application of the quotient rule and the negative laws of exponent. So we have now 24a cubed b raised to 7 c over 32a raised to 5 b raised to 4 c cubed. So what are we going to do is we have to what do you call this one? Simplify or divide constant to constant and then variables to variables. So we have now applying now the quotient rule. So we have now 24 divided by 32 times factor out the given expression a cubed minus minus 5, okay, or a cubed divided by a raised to 5, it will give us an answer which is equal to a raised to 3 minus 5 times b raised to 7 divided by b raised to 4, keep the base which is equal to b, and then subtract the exponent 7 minus 4. Same with c variable 1 minus 3. After that, we simplify 24 divided by 32. What's the common factor of 24 divided by 32? Both are divisible by 8. So the highest factor or the greatest common factor of 24 and 32 is 8. So 24 divided by 8, that is 3 over 32 divided by 8, that will give us 4. So 3/4 is the simplest form of 24 over 32. We proceed with the variables. A raised to 3 minus 5, that will give us a raised to 3 minus 5 is equal to negative 2. While b raised to 7 minus 4, that will give us b raised to 3. And c raised to 1 minus 3, that will give us c raised to negative 2. What will we do with the negative exponents? All expressions that contains a negative exponents, get the reciprocal of the base and then take the positive exponents. So we have 3 over 4 a raised to negative 2. Sa taas po ba siya or sa baba? Sa baba. Okay, so magiging a squared na siya. And then yung b cube, sa taas po ba siya or sa baba? Sa taas pa rin siya. Why? Because its exponent is a positive 1. So hindi natin siya ibababa. How about c raised to negative 2? Sa taas, baba. Very good. Sa baba pa rin siya. Why? Because negative ang exponent niya. So our final answer would be 3b cubed over 4a squared c squared. So those things are under the application now of the quotient rule and the negative law of exponent. Next, we proceed. We now proceed with the 7th law of exponent, that is the zero law of exponent. Kapag sinabi nating zero law of exponent, any base powered by zero exponent equals 1. Okay? So, kapag sinabi nating zero, okay, zero law of exponent, we say that any base that is being raised to 0 is equal to 1. Say for example, we have a raised to 0. A is our base. It is being raised by 0. It's equal to 1. Another example, say for instance, we have 2xy. The quantity 2xy raised to 0 is equal to 1. Okay. Next, we have 3x cubed y over z, the quantity raised to 0 is equal to 1. 1 million raised to 0 is equal to 1. So that's how simple we use, or we are going to apply now the zero law of exponent. Any number, any variable, or anything that is being raised to 0 is equal to 1. So that's the 7th law of exponent. The zero law of exponent. Okay? So I want you to always remember that when we say quotient rule, what will you do? What is the rule? You have to copy the common base and you have to subtract the exponents. While for the power of a quotient, what will you do? You have to distribute the exponent to the quotient. And the last one, we have the negative law of exponent. What will you do? You have to get the reciprocal of the base with the negative exponent, then make it positive. We also have the zero law of exponent, which says that expressions that are being raised to 0 is always equal to 1. So that's it. So those are the different laws of exponents. I hope you have learned something with the discussion and you prepare very well for your upcoming synchronous assessment that will be on Friday. Thank you so much for listening and goodbye everyone.